In this video, I'm going to talk about z-scores. And so a z-score is essentially the number of standard deviations that a data value is away from the mean for a normal distribution. And so if I look at this example down here, it gives me two normal distributions. One's for the height of men, and the other is for the heights of women. And so for men, I see that there is a height of 69.4 and a standard deviation of 3.1. But for women, there's a mean of 63.8 and a standard deviation of 2.8. And then it asks a question that I'll answer in a second. But real quick, let me define z-value through an example. And so what I mean by being so many standard deviations away from the mean is if I draw out this normal curve for men, it's going to be centered at 69.4. And then one standard deviation away would be 72.5. And so here, 72.5 is one standard deviation away from the mean, which means it should have a z-score of 1. So that was just a quick example to show what a z-score is and what it represents. And so now we can use this to find z-scores for values that are not exactly one standard deviation or two standard deviations or three standard deviations away from the mean, but we can find values that are 1.23 standard deviations away from the mean. And so if we look at the question, it's asking us, who is taller relative to their gender? A single man that is 73 inches tall or a single woman that is 68 inches tall? And so to answer this, we're going to have to find the z-scores of both 73 and 68 and figure out how many standard deviations away they are from their means. For the first data value of x equaling 73, we're going to find its z-score by using the mean and standard deviation given for men. And so we're going to have 73 minus 69.4 divided by 3.1, which will give us 3.6 divided by 3.1, and this gives us 1.16. So a data value of 73 has a z-score of 1.16. The next data value of x equaling 68, to find its z-score, we're no longer going to use the mean and standard deviation for men, since we're now looking at the height of a woman. We're going to use the mean and standard deviation for women. And so here, its z-score is going to be 68 minus 63.8 over 2.8, which results in 4.2 divided by 2.8, which gives a z-score of 1.5. And so here, we can see that a data value of 68 inches for women is farther away from the mean than a data value of 73 inches is for men. And so the answer to this question is a woman 68 inches tall is taller relative to her gender. So the interpretation that we're getting here is that the amount of cheese on the selected pizza was 2.2 standard deviations below the mean, which means that the pizza parlor is not in danger of closing. So not in danger of closing. In this example, we're given a normal distribution with mu 17 and sigma 3. So mu is 17 and sigma is equal to 3. And it says it took someone 20 minutes to get to class one day. Would we expect the z-score to be positive or negative? And so here, because this data value is greater than the mean, we would expect our z-score to be positive. Part B is asking how many standard deviations the mean is from 21 minutes. To answer this, we need to find the z-score. So that's the definition of z-score. So how many standard deviations from the mean? This is the z-score. So when you find the z-score here, you're going to get 21 minus 17 divided by 3, which is going to give you 4 over 3, which equals 1.33. So it's 1.33 standard deviations from the mean. For this last one, part C, what commuting time corresponds to a standard score of z equals negative 2.5? What we need to figure out here is we need to figure out the value of x. So if you look at the formula, z equals x minus mu divided by sigma, we're given 3 out of the 4 pieces here, and rather than having x this time, we're actually given z, mu, and sigma. So what we can do is we can take this equation and we can solve it for x, and then we can plug in all 3 of those pieces. So to solve this equation for x, you're going to first multiply both sides by sigma. Here they cancel, and so you have z times sigma is equal to x minus mu, and then you just add mu to both sides. And so you get that x is equal to mu plus z times sigma. So if I want to find the x value here, I'm going to have 17 plus negative 2.5 times sigma, which is 3. And this gives an x value of 9.5. And so here my units would be 9.5 minutes.